Find the lengths of the sides of the triangle PQR. Is it a right triangle? Is it an isosceles triangle? You can see P is the point 3, negative 2, negative 3. Q the point 701, and R is the point with coordinates 1, 2, and 1. So these points exist in R3. It would be a little bit difficult to try and draw these 3 points and draw the triangle, but we don't need to actually see the triangle to determine if it's a right triangle or an isosceles triangle. We're going to find the lengths of the sides as suggested and determine based on those numbers. So we're going to use then the distance formula for 3 dimensions, and we'll start by finding the length of the side PQ, the distance from point P to point Q. And of course the distance formula for 3 dimensions says we're going to take the square root of the difference of the x values, so we can take 3 minus 7 and square that, plus the difference of the y values, negative 2 and 0, square that, and then plus the difference of the z values, negative 3 minus 1, and square that. And that's equal to the square root of, well, 3 minus 7 is negative 4, and negative 4 squared is 16. Negative 2 minus 0 is negative 2, and negative 2 squared is 4. Negative 3 minus 1 is a negative 4, and negative 4 squared is 16. 16 and 16 is 32. 32 and 4 is 36, and the square root of 36 is 6. So that is the length of side PQ of this triangle. Let's go ahead and find the length of PR. So the distance from point P to point R, which again, using the formula for distance in 3 dimensions, we're going to take the difference of the x values and square it. So 3 minus 1 squared, plus the difference of the y values, negative 2 and positive 2. That's a change of 4 there. Be careful with your minus signs. So negative 2 minus 2, we're going to square that, plus the difference in the z values from negative 3 to 1. That's again going to be a difference of, well, 4 the way we have it subtracted, but when we square that we'll get 16. So we have 3 minus 1 is 2, 2 squared is 4. Negative 2 minus 2 is, let's see, that is negative 4, and negative 4 squared, of course, is 16. And negative 3 minus 1 is negative 4. Negative 4 squared is also 16. And so we have, again, the square root of 36, or 6. So PQ and PR are sides of the triangle that have the same length. Let's go ahead then and find the distance from Q to R, the length of side QR on this triangle. So again, using the distance formula for 3 dimensions, we're going to take the difference of the x values, 7 minus 1, and square that. We'll take the difference of the y values, 0 and 2, 0 minus 2, and square that. And finally, the difference of the z values, well, there is no difference there. 1 minus 1, that's going to give us 0. And so we have the square root of, well, 7 minus 1 is 6, so we have 6 squared, or 36. Negative 2 squared is 4, so 36 plus 4, and then 1 minus 1 is 0. So we have the square root of 40, or if you like, we can break that down to 2 times the square root of 10. Well, we can see that since we have 2 sides of the same length, namely PQ and PR, those are the same, we do have an isosceles triangle. So the triangle is isosceles. I guess we answered the second question first. Now, is it a right triangle? Well, the answer there is going to be no. If it was a right triangle, the longest side, which is the square root of 40, would have to be the hypotenuse, and the squares of the other 2 sides added together would have to equal the square of the hypotenuse. Well, since PQ squared plus PR squared, those are the 2 legs of this triangle, if it is a right triangle, that's equal to 6 squared plus 6 squared, which is 36 plus 36, or 72, does not equal what would be the hypotenuse squared, the square root of 40 squared, which is 40. 72 does not equal 40. The triangle is not a right triangle. So we did have an isosceles triangle, but we did not have a right triangle.